You know, every single day there's this massive invisible force shaping your world. It's in everything from the route your map app suggests to the products you see pop up online. Well, today, we're going to pull back the curtain on that very force, big data.
I mean, think about it. Have you ever been driving and wondered, how on earth does my map app know about that traffic jam just up ahead? Like almost as it's happening? It seriously feels like magic, right? But what's really going on is actually way more interesting.
Yeah, it's not magic at all. It's the result of analyzing millions, and I mean millions, of data points every single second. It's pulling info from other drivers' phones, from sensors on the road, even from old traffic patterns. And that, right there, is the power of big data in action.
Okay, so we've established that big data is super powerful. But what actually makes data big? It's a great question, because it's not just about the sheer amount of it. Turns out, there are a few key characteristics that completely change the game. So let's dive in and break down its anatomy.
All right, here's a good way to think about it. If your regular, everyday data is like a glass of water you can easily hold, then big data, well, it's a tidal wave. It's just so massive, so fast-moving, and so complex that the tools we're used to, like a simple spreadsheet, they just can't contain it. No way.
So to really get a handle on big data, experts often talk about what they call the 5 V's. First, you've got volume, which is pretty obvious, the sheer scale of the data. But then there's velocity, which is the incredible speed it's all created at. Think about a stock market feed or social media. It's constant. You also have variety, because this data isn't just numbers. It's text, video, audio, you name it. And if you can get a handle on all of that, you can unlock the final and, honestly, the most important V, value.
And just to give you a sense of what we mean by volume, get a load of this number. An IDC report predicts that by 2025, the world will be generating about 163 zettabytes of data. Now, what's a zettabyte? Well, that number is a staggering 163 trillion gigabytes. It's almost impossible to wrap your head around.
So this whole data explosion feels incredibly modern, right? But the thing is, our desire to collect information is, well, it's ancient. The only real difference is the scale. So how did we get from, clay tablets and scrolls all the way to zettabytes of digital info? Well, the whole journey really happened in a few distinct leaps.
You can see the evolution so clearly on this timeline. I mean, we started with these very early attempts at collection, right? Like the great ancient libraries. Then, fast forward to the 70s, and we get structured databases, basically super organized digital filing cabinets. But the real game changer, the thing that blew the doors off, was the internet. Suddenly there's this chaotic flood of unstructured data. And now, we're smack in the middle of the third wave, where our phones and smart devices are pumping out a constant, real-time stream of data.
Okay, so this brings up a pretty huge question. With this just relentless flood of data coming at us, how in the world do we manage it? How do we make any sense of it at all? Well, you can't use a bucket to stop a flood, right? The old solution of building these rigid local data centers just wasn't going to cut it. The real answer was to move to the cloud. I want you to think of it like renting a warehouse that can instantly expand or shrink depending on what you need. That's exactly what cloud computing does. It gives us that flexible, on-demand power we need to process this totally unpredictable data deluge.
So once the data's in the cloud, how do you actually handle it? Well, there are 2 really popular strategies. Let's imagine you need to know 2 things: the exact average rainfall for the last 10 years and whether it's raining right now. The Lambda architecture tackles this with 2 separate paths. It has a cold path, which is like a slow, scenic route for deep historical accuracy, and a hot path, which is like an express lane for super fast, real-time updates. Then you have the Kappa architecture. It's simpler. It just uses one single high-speed lane for everything. If it needs a deeper historical look, it just reanalyzes the original data stream.
Okay, so all this technical stuff is pretty interesting, but what does it actually do for us? This is where it gets really exciting, because this is where we see how all that processed data gets turned into actual decisions that affect our daily lives, and everything from healthcare to the way we shop. Seriously, big data's impact it's everywhere. We're talking retail, healthcare, finance, manufacturing, even agriculture. It's optimizing supply chains, personalizing our shopping, powering markets, helping farmers grow more food. It's fundamentally reshaping pretty much every single sector of our economy.
Okay, let's take retail, for example. You know those product recommendations you see online? They are not random, not at all. Behind the scenes, predictive models are constantly analyzing every click you make, your purchase history, and even what other shoppers like you have bought. all to suggest things you might actually want, and it does it in real time.
And then you have healthcare, where the stakes are obviously so much higher. Hospitals can now analyze thousands and thousands of patient records to build models that can actually predict which patients are most at risk of being readmitted. And that knowledge is powerful. It lets them provide targeted follow-up care, which can ultimately save lives and improve patient outcomes.
And the potential value here is just staggering. I mean, check out this quote from McKinsey. They estimated that if U.S. healthcare just used big data creatively, the sector could create more than 300 times billion dollars in value every single year. That's just by improving efficiency and patient care. Incredible.
So, okay, the power and the potential of big data, they're undeniable. But, as you can probably guess, this incredible capability, it doesn't come without some pretty big risks. And as we look to the future, it forces all of us to confront some very difficult questions.
The benefits are clear, for sure, but so are the dangers. We're talking about huge challenges to our privacy and really fundamental questions of control. As surveillance becomes easier and these algorithms get smarter and smarter, the one question we all have to ask ourselves is this: who is really in control? Who's in control of our data, and who is making sure it's being used for good? That right there, that's the conversation that is going to define